Okay, one last example, my apologies. Is the Cartesian product commutative? Why or why not? We did Cartesian product last time. And if you remember, this is a collection of ordered pairs. Do you remember that? We looked at them over here. Right here. And we had all these collection of pairs. It says x1, x2, y1, y2, z1, z2, and so forth. And the question is it commutative? Now, commutative we've talked about as well. Not at length, but we have talked about commutative. Commutative is the idea of switching numbers around. So we've talked about how addition is commutative, right? 5 plus 2 is the same as 2 plus 5. Well, in order for the Cartesian product to be commutative, it would mean that the ordered pair, for example, from the last example, x1, is equal to the ordered pair 1x. That when we switch the numbers around, or the letters around, or whatever, the ordered pairs around, we have the same thing. What do you think? Is that true? Oh, that's a good question. And this definitely lends itself to graphing. So if we are graphing, so if that's the answer to your question, Hannah, what do you think you would have? If you're correct, if we would be talking about a graph, would the ordered pair, let's just use some numbers, like 1, 3. Would the ordered pair 1, 3 equal the ordered pair 3, 1 on a graph? No, it wouldn't. Right? And a graph is definitely an example of one of these types of Cartesian products. So in general, no.
Would it be the same with like addition and subtraction, like 5 and 2? You can't, like the sum is different when it's like 5 minus 2 or 2 minus 5.
You're thinking about subtraction. Subtraction is definitely not commutative. That's true. And we will do that in chapter 3. We're going to talk about commutative more when we get there. Right now we're talking about commutative just for the purposes of these ordered pairs. And so for ordered pairs, because they do lend into graphing, which is the kind of the point behind doing them, they don't work to be commutative. For subtraction, they don't. Commutative doesn't work. For addition, it does. Okay, so it really depends on what we're talking about. And on this one, we're talking about ordered pairs. So in general, no, because right here, this fails. The ordered pair 1, 3 is not equal to the ordered pair 3, 1. Now, just to kind of throw you a little bit of a difference, what if you had the ordered pair 2, 2? Would that be commutative? Yeah, but it's very specific, right? It's a repeated number. So in general, it's not commutative, but there are examples where you could say, it does work on this one though. Right? I could switch those numbers around and we'd be totally cool.